Section 2.3, other set operations and their properties. So we're going to look at several operations on sets in this section. And the first operation we're going to look at is called set intersection. So we're going to have this running example to help us illustrate the operation. So let's look at the set C is the set of all x such that x is a college graduate, and S is the set of all x such that x earns at least $40,000. Suppose I want to mail a questionnaire to the individuals in a certain city who are college graduates and who earn at least $40,000. The individuals to receive the questionnaire have to belong to both C and S. And so this is called the intersection of C and S. So here's my universe. Here's my set C and my set S. And the overlap here is my intersection. So we think of this as S and C, right? We wanted people that are in both sets, S and C. So the key word here is and. And our notation here is S intersect C. So we read this as S intersects C, and the word you want to think is and. So things in both. In general, the intersection of two sets, A and B, written as A intersect B, is the set of all elements common to both A and B. So using notation here, we have A intersect B is the set of all x, such that x is in A and x is an element of B. So let's try doing that for some examples, okay? So our first set, A is the set consisting of 1, 2, 4, 5, and 6. And B is the set containing 2, 4, 6, and 8. So I want to know what elements are in A and B. So they both have a 2. So I'm going to put 2 in my intersection. They both have 4. So 4 goes in my intersection, and they both have 6. So 6 goes in my intersection, and that's it. The other elements are only in one of the sets, not in both. How about part B? Here I have A is 1, 3, 5, 7, and so on. So the odd integers, positive integers. And B is 2, 4, 6, 8. So even whole numbers. And so on. So what's in the intersection here? Well, A is all odd numbers and B is all even numbers. So there is nothing in their intersection. When there's nothing that's common to both, we write the intersection as the empty set. What about A, again, is going to be the set of odd whole numbers, and now B is going to be the set of natural numbers, so 1, 2, 3, 4, 5, and so on. What's the intersection here? Well, here, if you notice, my set A is contained in B, right? So if you remember our notation, A is a subset of B. Everything that lives in A also lives in B. So the intersection here is all of A. Everything in A is also in B. Okay? And in general, if A is a subset of B, then A intersect B will just be all of A, because everything in A is also in B. Okay, so the key word here is the word and, right? So anytime you see intersection, what you should think to yourself is and. So let's look back at our example of college graduates as our first set and people earning at least $40,000 in our second set. Suppose we know that 4,800 individuals have college degrees, 5,400 earn at least $40,000, and 1,200 have a college degree and make at least $40,000. Then we want to answer these questions. Now we can use a Venn diagram to help us sort of fill in these numbers. So let's look at what we know here. I know that 4,800 individuals have college degrees. That's the number of people in C, right? So I know that N of C is 4,800. I also know that 5,400 earn at least $40,000, so N of S is 5,400. Now, what is this last number? 1,200 have a college degree and make at least $40,000. Those are the people that live in the intersection. So this yellow shaded region, there are 1,200 people in there. And that is my N of C intersect S. So if I want to figure out how many people live in this region that's outside of the intersection but still in C, well, the number of people that live here or that belong in this region is going to be the number of people in C, the 4,800, minus the 1,200 in the intersection. So that's going to give me 3,600 there. And similarly, I can look at the number of people that will be in S, but not in the intersection of S with C. So the number of people over here is going to be 5,400 minus 1,200. And so that's going to give me 4,800. I'm sorry, not 8, 4,200. Okay, so let's see if we can answer these questions. How many have college degrees but earn less than 40,000? Well, that's exactly this region here, the number of people in C but not in C intersect S. So this is going to be 3,600. How many people earn at least $40,000 but do not have a college degree? That's going to be this region here in S that we just found, and there are 4,200 people there. All right.